are small. There are only 20 annual observations, 25 annual observations, cross-section data are small. So they have to rely on mainly the parent sample properties. The samples are small, but now the samples tend to be reasonably large. So the large sample properties can be used. And the large sample properties have received a lot of attention in recent literature. So that is one aspect which is discussed in the genus in section 3 above, holders and references which are not quite appropriate concepts of covariance stationality and peak dependence play an important role in ensuring consistency and reciprocal normality of the algorithm. The focus in modern econometrics is on large sample properties because large samples are available for analysis and large sample properties are consistent and reciprocally large. That is the data wireless converges to the population parameter. That is the property of it. Data wireless tends to have a normal distribution in the sample that is large. These are important properties, and the concept of covariance stationality, peak dependence plays an important role in ensuring consistency and reciprocity are does not depend upon me. Depends only on the distance to the distance. Here this is not superior activity, this is not activity. They are separate slightly in the distance stage. So the covariance depends on distance, but not on the particular time point because that is covariance station. For all edge 0, 1, 2, so on, that is the property of covariance station. So what it means is, over time, the moment, the second order moments do not change. Second order moments could be covariance or a variance, they do not change.
This gets normally violated in the time series. That's the. Is this assumption normally gets violated in the time series? That's take the GDP over time, it's increasing. So this assumption normally.
Assuming that this does not really hold in the case of GDP.
Or money supply or macro variables.
Because the mean also is changing over time, variance is changing. But if those assumptions are tenable, then in that case, your properties will be discussed earlier in the course. That is what I'm discussing again. What is the property of covariance? Then the property of peak dependence. That is again an important property. What definition is not really easy. Intuitively, a function is widely weakly dependent and the relation is weakly dependent. The correlation coefficient between widely and edge tends to 0 quickly as the distance between checkpoints varies. That is, the common element between this year's value of the variable and the value of the variable that 10 years ago should be very low. And if distance increases, that correlation should tend to 0. That's graphic, that's the idea of There is dependence. If the dependence is big in the sense that correlation tends to zero as necessary. This is not true of all time series. Time series is a good property of that weakly dependent time series. And there are some examples of weakly dependent time series.
So that means that dependence remains between two observations, but what like the downward trend is?
That is,
So the dependence trend is actually reducing over the period.
yes.
Can we say something like a moving average versus the autoregressive? Autoregressive is a long-term memory, but moving average is a short-term memory.
Coming to some examples of weak dependence. Examples of weakly dependent process are white noise process.
Okay, that's the move. Random computer.
Any two members are uncorrelated, therefore. Second is a moving average of order 1 process. Moving average of order 1 process is yt is equal to alpha epsilon t alpha epsilon t, where epsilon t is white noise. White noise is easily independent, common variance and so on. So when the PR1 process yt is equal to, that is strictly dependent, provided this coefficient going is right minus 1 is less than 1 in absolute sense. And the trending process, that is the determinant trending process, yt is equal to alpha beta t epsilon t, where epsilon t is white noise, that is also a
Weekly.
weakly dependent. It is not convergent, it is non-stationary. This is non-stationary, but this value here is weakly dependent. Because if you consider the covariance between yt and vertical z, that will lead to this. I think this is discussed over to use the voltage. Quite well included.
So in this definition, what is the significance of writing the word quickly?
Fine.
In the definition of weak single table,
Yeah.
we are saying it's convergent to zero.
Yeah.
Quickly.
Quickly.
Why?
That is,
If it is quickly convergent to zero, we will not say that quickly. Or does it have a significance?
yes, that is right. This notion is not very rigorously defined. The notion of weak dependence. But it is a very important notion. And the notion, the concept is that the correlation should eventually tend to zero, but eventually may take long time. But that period is required to be small. Okay. Again, as I mentioned, it is not a, but it is operationally it is a convenient assumption. But from the point of view of a rigorous definition, there is no rigorous definition of weak dependence. So if it takes